Welcome. Today we will be discussing the various design issues in computer networks. Computer networks are complex systems that require careful planning and design to ensure that they function effectively and efficiently. In this lecture, we will discuss some of the key design issues that need to be considered when designing a computer network. Scalability. One of the key design issues in computer networks is scalability. Scalability refers to the ability of a network to handle an increasing amount of traffic as the number of users or devices connected to the network grows. The network must be designed with scalability in mind, taking into account the potential for growth and ensuring that the network can be easily expanded to accommodate additional devices and users without disrupting existing operations. Reliability and availability. Reliability and availability are also important design considerations in computer networks. A reliable network should have redundant components and mechanisms in place to ensure that data can be transmitted and received even if one or more components of the network fail. High availability means that users can access the network and its resources at any time, without interruption. Security. Security is a major concern in computer network design. The network must be designed to protect against unauthorized access, data theft, and other security threats. This can be achieved through the use of firewalls, encryption, and security protocols to ensure that only authorized users and devices can access the network and its resources. Performance and bandwidth management. Performance and bandwidth management are essential to ensure that the network functions smoothly and efficiently. The network must be designed to allocate bandwidth and resources to users and applications as needed, taking into account the amount of data that needs to be transmitted, the number of users and devices connected to the network, and the type of applications being used. Latency and delay. Latency and delay refer to the time it takes for data to be transmitted from one point to another within the network. In a well-designed network, latency and delay should be kept to a minimum to ensure that data is transmitted and received quickly and efficiently. Interoperability and compatibility. Interoperability and compatibility refer to the ability of different devices and systems to work together seamlessly within a network. The network must be designed to accommodate the diverse range of devices and systems that may be connected to the network and ensure that they can communicate and exchange data effectively. Routing and congestion control. Routing refers to the process of directing data from one point to another within the network. Congestion control refers to the mechanisms used to manage the flow of data within the network to prevent overloading and ensure that data is transmitted and received efficiently. The network must be designed to take into account routing and congestion control to ensure that data is transmitted and received effectively and efficiently. Power consumption and energy efficiency. Power consumption and energy efficiency are becoming increasingly important in the design of computer networks. The network must be designed to consume minimal power and use energy-efficient components to reduce the carbon footprint and costs associated with operating the network. In conclusion, the design of a computer network is a complex and challenging task that requires careful planning and consideration of a wide range of design issues. Scalability, reliability and availability, security, performance and bandwidth management, latency and delay, interoperability and compatibility. Also routing and congestion control, power consumption, energy efficiency are all important design considerations that must be taken into account when designing a computer network. Thanks for watching.